Okay guys, so now that we've learned how to graph angles, we're going to look at something new. So hopefully graphing angles, some of that was review. Today we're going to learn a different way to graph some angles. It's going to be brand new for most of you guys, and that is using something called radians. Okay, so there is actually, every angle that you graph, you can actually name using two different measurements. You can either measure it in degrees, which is what all of you are used to, or radians. Okay, so degrees is what we're used to, and that is, if I were to measure this angle here from the initial side to the terminal side, that theta, that's my degrees, the number of degrees it takes to get from the initial side to the terminal side. Now, if I were to have an arc here, the radians actually is just it's the length of that arc of that angle. Okay, so every radian has an equivalent degree, and every degree has an equivalent radian measurement. It's just two different ways of looking at it. So we're going to look at how to convert between the two, but first we're going to look at how we really figure out what radians are. Alright, so like we said, the radian is the length of that curve of that arc. So if I were to take a full circle here, alright, I know that that full circle is 360 degrees. But let's say I want to measure that in radians. Okay, so I want to know the circumference of that circle. Let's say that this radius here is just 1. Okay, if that radius is 1, then my whole circle, the circumference of that circle is measured as 2 pi r. So that means that that full circle there, as that radius is 1, is 2 pi. So what we're going to do is we're going to say that 2 pi is basically our standard measurement for 360 degrees. Okay, so one full circle in radians is 2 pi. So in order to find coterminal angles for radians and degrees, if we added or subtracted 360 if it was in degrees, in order to add or subtract something in radians, what we're going to add or subtract is 2 pi. And again, just like we did with degrees, we can add or subtract 360 as many times as we wanted to. So what we're going to do is let's take a basic angle. Let's say I have the angle pi over 6. Now, not every radian measurement that you have is going to have a pi in it. It doesn't have to, but a lot of the common ones that we're going to look at this year will have pi. So let's say I have the angle pi over 6, and I want to find a coterminal angle to that. Well, what I would do then is I would either add or subtract 2 pi. So let's say I want to add 2 pi. Now this is the reason why it's important for us to know how to work with fractions. Because in order to add 2 pi, I can't just add across and say it's 3 pi over 6. That doesn't work. In order to add fractions, I have to have a common denominator. So if I make this over 6, I need to multiply the top by 6 and make that 12. Which means that actually what I'm going to have here is 13 pi over 6. And it would be the same thing if I subtracted 2 pi. I would have pi over 6 minus 2 pi, but I would need that common denominator, so it would actually be minus 12 pi over 6. And when I subtract and add fractions, I just go straight across the top and straight across the bottom. I can add pi's with pi's, so if I have 1 pi and I take away 12 pi's, then I have negative 11 pi's over 6. So again, coterminal angles with radians are really just to help you guys, or really just extra work with fractions. They're not as bad, but you have to know how to work at it with fractions. Okay, so the next one we're going to look at is how we convert back and forth between degrees and radians. Okay, so if I can always take a degree measurement and turn it into a radian measurement, and I can take a radian measurement and I can turn it into a degree measurement. So in order to convert from degrees to radians, let's see what we know for sure. We already know that 360 degrees is the same thing as 2 pi. That's what we just did at the very beginning. So if 360 degrees is equal to 2 pi, then we know that 180 degrees is equal to just pi. So in order to convert degrees to radians, what we need to know is what 1 degree is equal to in radians. So if I know 180 degrees is equal to pi, if I want to get 1 degree by itself, I'm going to divide both sides by 180 degrees. So that tells me that 1 degree is equal to pi over 180. So in order to convert from degrees to radians, what I'll do is I'll take my degree measurement and I'll multiply by pi over 180. Okay, so for example, if I have 90 degrees and I want to convert 90 degrees to radians, what I would do is I would take 90 degrees and I would multiply that by pi over 180. Now remember, with adding and subtracting, I needed a common denominator, but I don't when I multiply. So when I multiply, I'm just going to multiply straight across the top, and that's 90 over 1, so I get 90 pi over 180. And then I can simplify that fraction, which simplifies to pi over 2. So that means that 90 degrees is the same thing as pi over 2 radians. Okay, so I take my degrees and I multiply by pi over 180. Let me go ahead and add degrees. So degrees times pi over 180. Now let's say I want to go the other way. I want to convert radians to degrees. Well, I know that 1 pi radian, so pi radians, is equivalent to 180 degrees. So again, if I want to convert this, I need to see what one single radian is. Remember, 1 pi is not the same thing as 1 radian. Okay, a pi radians is actually 3.14, 159, etc., radians. So 1 regular radian, I got to divide both sides by pi. And that gets 1 radian by itself. So I know that 1 radian is equal to 180 over pi. So what I need to do is, in order to get my radians to degrees, is I take my radian measurement and I multiply that by 180 over pi. So let's say, for example, I have the degree pi over 6, the radian value pi over 6, and I want to convert that to degrees. Then I would take pi over 6, and I would multiply that by 180 over pi. Multiply straight across the top, multiply straight across the bottom, and I get 180 pi over 6 pi. And then I can reduce this. My pi's cancel out, and 180 divided by 6 is 30 degrees. So pi over 6 radians is the same thing as 30 degrees. Now sometimes it is difficult to keep these two straightened out, which one goes with radians, which one goes with degrees. One way you can remember it is it's common. Although it's not required, it is common for radians to have a pi at the top. So if I want my final answer to have a pi at the top, so if I want to convert from degrees to radians, I need to multiply by the one that has the pi at the top. And if I usually start with a pi at the top, when I'm converting this way, I need to multiply something that's going to cancel out the pi, which puts the pi at the bottom. Alright, so the last thing we're going to look at is how to graph some radians. And what we're going to do is we're going to start, actually before we graph these, we're going to start and look at some of the most common radian values that we're going to graph. Okay, and that's going to be on something called the unit circle. So all of you guys got a copy of this in class, or you'll get a copy of this in class. And this is what's called the unit circle. We call it the unit circle because we say that the radian, or the radius there of that circle is 1 unit. So we pretend that that distance is 1. Now the reason for that is because we know if that distance is 1, it's that full 2 pi all the way around. So it's kind of our basic standard measurement here. So what we're going to do is we're going to fill in some of these basic values on our circle. Alright, these are the ones that you're going to see the most often this year. And we're going to start with some of the easy ones. So the very first ones we're going to start with are these two values right here, because we've already looked at them. Okay, I know, well, the line's not very straight, but I know that that very starting point is 0 degrees. I know that's going to be, as well, it's going to be 0 radians. Now if I go all the way around in a full circle, it's the same thing as 2 pi radians. Then I also know halfway around the circle is 1 pi radian. And the next two we're going to fill in, hopefully are pretty simple. Okay, all the way at the top of my circle, I'm going to have halfway between 0 and 1 pi, which is half of a pi. But we don't write it as 0.5 pi or 1/2 pi. What you're going to see these written as are improper fractions. You're going to see that written as pi over 2, which is what we actually just found. We know that's a coterminal angle to 90 degrees. That's what we did at that the last example. Okay, but the way you'll see these radian values written a lot of times, you won't see not 0.5 pi. Okay, we want to use fractions because fractions are more exact. because if we get into, really specific decimals, we don't want to say 0.333 repeating pi. Okay, that's not exact enough. We want to use those fractions. And although pi over 2 is the same thing as 1/2 pi, you'll just see it written this way more often. So then I need halfway between pi and 2 pi. So halfway between 1 pi and 2 pi is 1.5 pi. But again, we're going to write that as that improper fraction. So halfway between 2 over 2 pi and 4 over 2 pi is 3 over 2 pi. So we're going to write that as 3 pi over 2. So that's my 1.5 pi. Alright, so then the next ones we're going to find are the ones that are halfway in between those. So we're going to fill in starting with these lines. So those are those halfways in between there. And that line was a little bit straighter. This one was not. Okay, so halfway between 1 pi and a half, or 0 pi and a half a pi, is 1/4 of a pi. And again, we're going to write that as pi over 4. And then halfway between half and a whole is 3/4. So we'll write that as 3 pi over 4. And if you guys notice, what I'm really doing here is kind of counting by pi's over 4. There's 1 pi over 4, there's 2 pi over 4, 3 pi over 4, 4 pi over 4, which means my next one would be 5 pi over 4, which is 1 1/4 still makes sense. Then this next one is 6 pi over 4, and then I have 7 pi over 4. Okay, now I'm not going to leave that 6 pi over 4 on there because then we know that reduces to 3 pi over 2. 4 pi over 4 we know reduces, and 2 pi over 4 reduces. But that's another way to help you easily figure out those middle radian values. Alright, then the next ones we're going to look at, I'm going to put them as 2 different colors, and we'll talk more about the reason for that later on this week. But I'm going to make these ones blue, and I'll make these other ones green. But we're going to do these at the same time. Okay, so this first blue line, that one is actually in degrees, that's 30 degrees. And we already know what that equivalent is, we just figured that out on our example. 30 degrees is the same thing as pi over 6. Then this next one, I'll just tell you that's 60 degrees in degrees, and 60 degrees is pi over 3 radians. So the easiest way to find all of these is, again, if you remember that pattern we just saw where we went from 1 pi over 4 to 2 pi over 4, there's actually something similar that happens here as long as we reduce. So right now I just drew 1 pi over 6. Well, if I go to that next green line, that would be 2 pi over 6. I'm going to skip the purples. My next yellow is 3 pi over 6, which means this next one would be 4 pi over 6. Skip the purple. 5 pi over 6. 6 pi over 6. 7 pi over 6. Skip the purple. 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. Right, and the reason we're counting like that is if you were to think about this in terms of just regular degrees, I'd be going from 30 to 60 to 90 to 120 to 150, all the way around that way. Alright, so again, you would just be, you wouldn't, when you're adding your 30, you would skip those purples because those would be at your 45s. So what I'm going to go back and do now is I'm actually going to simplify all these. Okay, so I have 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 I'm going to reduce to 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 does. 7 pi over 6 doesn't. 8 pi over 6 reduces. That's 4 pi over 3. 9 pi over 6 reduces to something you already have. 10 pi over 6 reduces. And then I have 11 pi over 6. So you guys can see part of the reason why I switched those two colors, but we're going to talk more about that again later this week. But as you guys can see, all the green ones have pi over 3 in some form, and all the blue ones have pi over 6 in some form. Alright, so these are my basic radian measurements that I'm going to use that will these are just the ones you're going to see the most often this year. So I'm going to go back real quick and fill in the degree values because those are a little bit simpler. So I know 0 degrees, I know 90 degrees, I know 180 degrees, and I know 270 degrees. And then filling in those in-betweens, I know halfway would be 45, 135, 225, and 315. Then I know I've got 30, and I'm going to count by 30s. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. So there's my degree values. And then again, if I went all the way around, I'd be at 360. Alright, now what I'm going to do is I'm going to use some of those basic values to help me figure out how to graph some more radians. So some radian values that don't fall on the unit circle. Okay, so let's look at a couple of these. Let's say I want to graph the radian value of 2 pi over 7. Now this is all about figuring out how to work with fractions. Okay, so what I'm going to do every time I graph a radian value, if you want to convert it to degrees you can, but it'll actually take less time and start to be a lot simpler if you just think about your fractions. Okay, so if I want to graph 2 pi over 7, I know this is 0 radians, this is pi over 2, this is pi, and this is 3 pi over 2. So what I need to do is I need to figure out where 2 pi over 7 is. Okay, so if I think about that, I know 1 pi, if I get a common denominator, is 7 pi over 7. So I'm going to rewrite that with a common denominator. This is 7 pi over 7. Well, I know 2 pi over 7 is less than that. So I know 2 pi over 7 has to either be in this quadrant or this quadrant. So now all I need to do is figure out, is 2 pi over 7, is that closer to 7 or is that closer to 0? Well, 2 is 5 away from 7, it's 2 away from 0. So it's got to fall in this quadrant. Okay, or if I were to look at it as half, I know half would be 3.5 over 7. So it would have to fall in that range. Okay, so it's just using what you know about fractions to help you figure out what quadrant it's going to fall in. Alright, so this one's a little bit tougher. Negative, because it's a negative angle. Okay, so if it's a negative angle, again, I'm going to draw my quadrants and figure out where these go. So I've got 0 radians. If I go negative, this is a negative pi over 2. This would be a negative pi, and a negative 3 pi over 2, and then a negative 2 pi. So it's a little bit easier to see. Again, some of you will probably be able to do this in your head, but if you don't, it's okay to change them to a common denominator to make it a little easier to work with. I know this would be negative 8 pi over 8 with a common denominator. Well, that means I'm going to have to go past here and past here, so I can't do that. If I were to go all the way around that full circle, negative 2 pi, that's negative 16 pi over 8 if I get a common denominator. Again, it's a little easier with that common denominator. Well, negative 15 pi over 8 is a lot closer to negative 16 pi over 8 than it is to negative 8 pi. So I know this angle will end in that quadrant. Alright, so then the last one here I have is 18 pi over 7. And again, I have my basic little borders here. There's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, if you're good with fractions and you have good number sense, you guys can already see this is going to be a problem because if I get a common denominator, 2 pi, that's 14 pi over 7. 18 pi over 7 is already bigger than that. So I already know I'm going to have to find a coterminal angle in order to graph this. So I'm going to subtract 2 pi, which is 14 pi over 7. So what I'm really graphing is a full circle and 4 pi over 7. So a full circle and that, this would be 7 pi over 7, this would be 3.5 pi over 7. So I know 4 pi over 7 would be in this quadrant, so I draw my full circle, and then I end here. Okay, and now I know, guys, radians are very, very, very new, and they will get easier to work with, especially as you get used to graphing them more often. You just have to remember it's really just working with fractions, and the more comfortable you are with fractions, the easier they're going to be.